Hello, in this lesson we will learn about quadrilaterals with emphasis on parallelograms. This is the first part of a two-part presentation about quadrilaterals. The learning goals are: understand how quadrilaterals are classified and understand the properties of parallelograms. A quadrilateral is a two-dimensional four-sided polygon, as we can see in this image here, with four vertices, in this example, vertex A, vertex B, vertex C, and vertex D, and four angles, in this example, angle A, angle B, angle C, and angle D. The sum of the interior angles of a quadrilateral total 360 degrees. So if we add angle A, the measurement of angle A, plus the measurement of angle B, plus the measurement of angle C, plus the measurement of angle D, we add all these four angles, we are going to get 360 degrees. Now, there are two general types of quadrilaterals. A convex quadrilateral is a quadrilateral in which each interior angle measures less than 180 degrees. For example, here we have a parallelogram, which is a convex quadrilateral, in which each angle measures less than 180 degrees. In a concave quadrilateral, one interior angle measures more than 180 degrees. That particular angle is going to be called the reflex angle. Here we have a concave quadrilateral because one of the angles, this one here, measures more than 180 degrees. That's the reflex angle. The word concave means curve inward. As we can see here in this quadrilateral, one of the sides seems that is being pushed towards the inside. That's a characteristic of a concave quadrilateral. Okay, now we're going to analyze the three main types of quadrilaterals we're going to study between this lesson and the next presentation, the second part of this presentation. This is like a general summary. First, let's start with parallelograms. In a parallelogram, we have two pairs of opposite sides that are parallel and congruent. Like these two sides are congruent, you see, I label them with blue, both of them. They will measure, or they will have the same length. And they are also parallel. We indicate that these two are parallel to each other by writing these arrows. These opposite sides here, labeled in red, are congruent and they are parallel, as indicated by labeling each of these sides with two arrows. There are three types of parallelograms: squares, rectangles, and rhombuses. The second type of quadrilateral we're going to be analyzing is the trapezoid. A trapezoid is a quadrilateral in which two sides are parallel to each other, and the other two sides are not parallel to each other. This is the exclusive definition. Okay? So basically, in the exclusive definition, only one pair of sides are parallel to each other, and the other pair is not parallel to each other. But there is another definition of trapezoids, the inclusive definition. According to this definition, at least one pair of opposite sides are parallel. So according to this definition, a trapezoid can look like this. It can have one pair of opposite sides that are parallel, or a trapezoid can look like a parallelogram in which two pairs of opposite sides are parallel to each other. So we're going to be focusing mostly on the exclusive definition of trapezoids to avoid confusion with parallelograms. But keep in mind that there are two definitions, and sometimes they will ask you questions considering this second definition here, the inclusive one. The third type of quadrilateral we will see or we will analyze is the kite. A kite is a quadrilateral in which one diagonal is a line of symmetry. So this diagonal here divides the kite into mirror images of each other. As a consequence of that, this pair of sides will be congruent, and this pair of sides will also be congruent to each other. That's why we label these two with blue, means this length and this length are the same, and these two with red, meaning these two have the same length. Okay? So that will be the definition of kite. Now let's focus on parallelograms. A parallelogram is a quadrilateral in which the opposite sides are parallel and congruent. Here, the same number of arrows indicate parallelism between segments. So again, these two sides have only one arrow, which makes these two parallel to each other, and these two sides have two arrows each, which make this one parallel to this one. Okay, so we indicate parallelism using the same number of arrows. The same number of tick marks indicate congruency between segments. So here, this side and this side are congruent, meaning they have the same length, because each one has one tick mark, or we label them with one tick mark each because we know that this length and this length are the same. Likewise, this side and this side, each one has two tick marks, which indicates that this side has the same length as this side. So to indicate congruency between segments or sides of a polygon, we use the same number of tick marks. Now let's focus on the angles in parallelograms. A parallelogram is a quadrilateral in which opposite angles are congruent and same side angles are supplementary. So let's draw this general parallelogram. Now let's draw parallel lines on top of these sides and parallel lines on top of these other sides. So if this angle is 60 degrees, this angle here will also be 60 degrees because they are vertical angles. This angle has to be 120 degrees because two angles that are on the same side of a line measure 180 degrees. They are supplementary. And this angle is vertical to this, so it has to measure 120 degrees as well. Again, this is an example. So basically, if we know one angle, we know all the other three angles in this situation. Now, because this line and this line are parallel to each other, right? The angles are going to be exactly the same. So this is basically two parallel lines intersected by a transversal. There is a previous video where I show these properties, so you can watch it if you want to get more information on this topic. But basically, these angles here and these angles here are the same. Same as these and same as these. So all of these are going to be the same. Now, what we're going to do here is going to erase all the exterior angles and just focus on the interior angles of the parallelogram. We can see that the opposite angles are congruent. This is 60, this is 60, and this 120, and this 120. So that's the first property about angles in parallelograms, that opposite angles are congruent. The second property says that same side angles are supplementary. So basically these two angles, if we add them together, they add up to 180 degrees. Same for these two angles, same for these two angles, and same for these two angles. So angles that are on the same side are supplementary. They add up to 180 degrees. Okay, now let's focus on the diagonals of parallelograms. In a parallelogram, the diagonals bisect each other. So if we draw this diagonal and this diagonal, this part and this part are going to be congruent. They are going to have the same length, okay? Because this other diagonal is intersecting them or dividing them in half. So this diagonal bisects this diagonal, cutting it into equal pieces. Likewise, this diagonal is bisecting this one. So this length and this length are going to be the same. Now, let's focus on the special parallelograms. The rhombus, the square, and the rectangle. The rhombus and the square both have 4 congruent sides, as we can see by the same tick marks here. The square and the rectangle both have 4 right angles, as we can see by these 90 degrees on each of the 4 angles here and here. The rhombus, or in the rhombus, I should say, diagonals are perpendicular, meaning that this diagonal and this diagonal intersect at 90 degrees. In a rectangle, the diagonals are congruent. This diagonal and this diagonal both have the same length. They are congruent. And in the square, the diagonals are both congruent and perpendicular. As you can appreciate in this graph, the properties of the square are the same properties of the rhombus and the rectangle together, right? The rhombus has 4 congruent sides, the square has 4 congruent sides. The rectangle has 4 right angles, the square has 4 right angles. The rhombus diagonals are perpendicular, the rectangle diagonals are congruent, so the square diagonals are both perpendicular and congruent. So the square basically is a mixture of the properties of the rhombus and the rectangle. Now, to understand better the properties of the diagonals in these special parallelograms, let's imagine that the rhombus is a fusion of 4 right triangles. So we have a right triangle. Okay, this is 90 degrees. I label this side, this leg with red, this leg with green, and this is the hypotenuse. So basically, we can create a rhombus by putting 4 identical right triangles together. Here we can appreciate that diagonals, this diagonal and this diagonal, are perpendicular, and the diagonals bisect their interior angles. So this diagonal divides this angle in half, right? This angle and this angle are the same. This angle and this angle measure the same. And this diagonal, the one in green, also bisects these 2 angles, right? So this angle and this angle measure the same. This angle and this angle measure the same. They are congruent. Okay? So that's a way to understand the properties of the diagonals by placing 4 identical right triangles together, and then we can clearly see these properties or come up with this conclusion. Now for the square, we can put 4 right triangles together, but these right triangles will have these 2 angles measuring 45 degrees each. So we have 1, 2, 3, and 4. So we can see that diagonals are perpendicular, and the diagonals bisect the interior angles. Each one will measure 45 degrees, right? As we can appreciate that. This diagonal is bisecting this angle. So the 90 degrees are bisecting into 45, 45, 45, 45, 45, 45, and 45, 45. For the rectangle, we can create that by putting 4 isosceles triangles together, but they are not identical. So this triangle here and this triangle here are congruent to each other, and this triangle here and this triangle here are congruent to each other, but all 4 triangles are not the same, as it is the case in the square and the rhombus, and there are no right triangles. Okay, so all we can really see here is that these diagonal and these diagonal are congruent. And well, these 2 angles and these 2 angles are congruent, and these 2 angles and these 2 angles here are congruent between each other. So it's a good exercise to create these parallelograms using triangles to understand their properties better. Now, we're going to go into a hierarchy of quadrilaterals. Basically, we're going to compare kite, parallelogram, and trapezoid with rectangle, square, and rhombus. Okay, so according to the definition, the rhombus is a parallelogram. Opposite sides are parallel and congruent. But the rhombus is also a kite, because according to the definition of a kite, there are 2 pairs of congruent sides, and you can divide a kite with one of the diagonals divides the kite into mirror images. And that happens with the rhombus. This side and this side are congruent to each other. That's 1 pair. And this side and this side are congruent to each other. That's a 2nd pair. Of course, all 4 sides are congruent, but it matches the definition of a kite, that there is 1 pair of congruent sides and there is another pair of congruent sides, and a diagonal divides divides the rhombus into congruent or mirror images. So the rhombus is a kite, and the rhombus is also a parallelogram, according to their definitions. Now, the square is a rhombus, because the definition of the rhombus is that it's a parallelogram and 4 sides are congruent. Here we have a parallelogram and 4 sides are congruent. But to be a square, you need to have 4 90 degrees angles. So basically, the square is a rhombus with 4 90-degree angles, 4 right angles. Now, the rectangle is also a parallelogram. Opposite sides are parallel, are congruent. And so the rectangle is a parallelogram, but the square is a rectangle too, because the definition of a rectangle would be a parallelogram that has 4 right angles. And in the square, we have a parallelogram that has 4 right angles. So the square is a type of rectangle. It's just that all 4 sides are congruent. Okay? So a square is a rectangle. Now, a trapezoid. The exclusive definition of trapezoid is that only two sides are parallel to each other. The inclusive definition says that at least one pair of sides are parallel to each other. So for the inclusive definition, parallelograms are also trapezoids. But for the exclusive definition, no. Finally, an isosceles trapezoid is a trapezoid that has only one pair of parallel sides, basically matches the exclusive definition. And the pair that is not parallel is congruent. So this length and this length are the same. And we will see more of that in the next presentation. So they can ask you questions like this. Are all squares kites? Well, let's see. Let's follow the arrows. We know that all squares are rhombuses and all rhombuses are kites. So yes, all squares are kites. Are all kites parallelograms? No. No, because there are only one kite, the rhombus, is a parallelogram. All other kites will not be parallelograms. So every time they ask you questions, you can use this diagram as a reference to answer them. If they ask you, for example, are all rhombuses kites? Yes. Are all kites rhombuses? No. Okay. So this is the diagram you can use to answer this type of questions regarding which figure is part of a different one. Okay, so that will be all for this lesson. Thank you very much for your attention.